Okay. Then we have to write the auxiliary equation for this. So the auxiliary equation is d raised to 4 plus 8d square plus 16 is equal to 0. Okay. Now tell me how to solve this. Am I audible?
Yes, ma'am. Yes, ma'am.
And is it visible?
No, ma'am. At right now, no.
Wait. Just check, and whenever it is visible, just let me know. Okay.
Yes, yes. It is visible.
Okay. Okay. Good.
Visible, ma'am.
Okay. 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 Then my question is how to solve this. Now there is not like a square plus b square or a square minus b square. If it is, we can add subtract, right? But now if we'll check this question, if you want to tell me answer in between, you just unmute and talk. Okay.
Okay, ma'am.
Okay. Then there are 2-3 ways I told you already. Yes, anyone? Okay. Then what to do is, first thing is you can substitute d square is some other variable, say s. So what we'll get here is s square plus 8s plus 16 0. Right? And this equation you can solve it on calculator. Or we can simply say 16 in 8. Can you factorize 16 in 8? That is 4 into 4. 4 into 4 is 16 and 4 plus 4 is 8. Right? So how can we write this?
Minus 4 minus 4.
Yes?
Minus 4 minus 4.
Minus or plus? If it is minus here, then we have to write minus. As yes, both are plus, you should write plus. So s plus 4 into s plus 4 is equal to 0.
Yes.
Right. 0. So, but s is what? D square. So, d square plus 4 into d square plus 4 is equal to 0. Right. So, what we get here is d square plus 4 is 0, 2 equations, and d square plus 4 is 0.
0.
Right. So what we are getting here is d square is minus 4 and d square is minus 4. Or on calculator you can solve. Take your calculator out. A is 1, B is 0, C is 4. Here is A is 1, B is 0,
D
C is 4.
equal to minus.
So D is equal to, or simply take square root here. What we get while taking square root? While taking square root, there is plus minus. Square root 4 is 2 and square root minus 1 is I. Same thing here. D is plus minus 2i. Correct? Or use your calculator, put A is 1, B is 0, C is 4, you will get this root. Okay. Then how is the nature of the roots? Imaginary, as I is there. Imaginary, okay, I'll write this. 0 plus minus 2i and 0 plus minus 2i. Imaginary and similar. Two are similar. So imaginary and repeated. Plus repeats twice, minus repeats twice. So two constants will be combined in the solution. So how will you write the solution? Y is equal to, alpha here is 0 and beta is 2. So how can we write? Y is equal to e raised to alpha x e raised to 0x into, as it is repeating twice, so you have to collect two constants, that is c1 plus c2x into cos beta x, beta is 2, plus c1 c2 done. Next, wherever was our c2, let me show you. E raised to alpha x into c1 cos beta x, c2 sin beta x. c1 will now replace, in this case, c1 plus c2x, and then c2 will replace c3 plus c4x, right? So c3 plus c4x into sin beta x, beta is 2. This is the solution for repeated imaginary roots. Have you seen this type? Have we seen?
No, ma'am.
Yes or no? I think yes. In
No.
first or
Yes, ma'am.
yes, yes. If it is repeating, imaginary repeating, then we have to collect the constants only, combine the constants. All other things are as it is, alpha as it is, e raised to alpha, cosine beta as it is, just change will be in the constant. If it is repeating like this 2 times, then two constants will combine. And if it is repeating 3 times, suppose there is the root again one more time, 0 plus minus 2i, then how could we write the solution? E raised to 0x. Can anyone help me out? If 0 plus minus 2i, 0 plus minus 2i, 0 plus minus 2i, suppose 3 roots are there, repeated 3 times, then how can we write the solution?
C1 plus C2 plus
C2x
Plus
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 C3x square.
C3x square. Very good.
square.
Into cos beta x. Now C3, up to C3 constants are used. So we have to use next constant. C4,
C4 C5 6
C5x plus
C4 plus
C6
C5x plus C6
x
x square.
into
Square.
sine 2x. Very good. Okay. Next question. Solve. D square plus 1 square d square plus d plus 1 raised to 4 y is equal to 0. Okay, as previously we have discussed, whatever is the order of the equation, that many roots will be there. That is 4 is the order, 4 are the roots, plus minus means 2, these are 2 total are 4. As 4 constants will also be 4. This should match. So now, can any one of you tell me what is the order, how many roots will be there, and how many constants there will be in your solution? So first of all, just tell me the order of this equation so that we can decide its number of roots. What is the order? What is the order? Highest power of D is called order. So can we just able to check what will be the highest power of D? If we multiply, if we do all the things, what will be the highest power?
6.
Is it 6? Just check it properly. Check it properly.
8, ma'am.
I think no. As there is multiplication again, you are forgetting multiplication. Base is same, addition of indices, that thing you are missing. So now what will be the order? Okay. What will be the term if we open it? Means highest power of D. We are just concentrating on highest power. D square, it's square. That is D raised to square. These two are in multiplication. So what is the term here is D raised to 4. Highest term in D. Highest power of D is D raised to 4 into. For second, I am just talking about highest degree. So D square raised to 4. So 4 into 2, that is D raised to 8 is highest in this case. Right? And but as there is into in between, base is same. So addition of indices happens. So what is the highest power? Is 12. Getting? So D raised to 12 is there. So there should be 12 roots and 12 constants in your solution. Right? Chalo, we'll together solve it. You have to consider the auxiliary equation. D square plus 1 square equal to 0. And t square plus d plus 1 raised to 4 is equal to 0. Right? That is what to do. Are you going to open it again? My question, huh? My question. Are you going to square this term again, or are you going to take fourth power again? Or no? If no, what to do? Very easy. Very easy. already factors are
No.
given to you. These are the two factors. This is twice. So we'll solve it once, and whatever we get the answer, we'll write it twice.
Twice.
Right? So we'll consider, from this, we'll consider d square plus 1 is equal to 0 and d square plus 1.
D square plus 1 is equal to
d square plus 1 is equal to 0. That is twice. Right? From this equation, d square plus d plus
4
1 is
times d square plus
0, and this should be how many times? 4
4
times.
times.
And I'll write here once, and I'll write in bracket 2 times. That is also okay. So same equation, so no need to write it again. So in bracket we can write this equation is 2 times there. Right? So solve this. D square plus 1 is 0. Beta?
D is equal to plus or minus I.
Consider. Okay. So d square plus 1 is 0. So while solving on calculator, put a is 1. Let me solve for you. So mode equation degree 2, a is 1, b is 0, c is 1. So x1 is 1i and minus 1i. So d square is d is plus minus I. How many times? 2 times. So whatever I am getting, I'll write it again, plus minus I. Right? Similar. Second equation, d square plus d plus 1. Solve it again.
Minus 0.5.
Minus 0.05 plus or minus 0.86I.
0.5 or
Minus
0.05? Just check it.
Minus
0.05.
0.5. No, ma'am.
Yes,
Only
ma'am.
minus
0.5, ma'am.
Okay,
Sorry.
0.5. Okay, minus sign is there?
Yes.
Yes, ma'am.
Minus 0.5 plus minus 0.86,
Plus or minus
right?
866.
86 I.
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 How many times? 4 times.
4 times.
4 times.
So I'll write. Can I write 4 times in bracket? Okay.
Yes.
Okay, 4 times. So that nature of the roots. This is of the type 0 plus minus I. This is 2 times. And this is, okay, this is proper. Alpha plus minus I beta 4 times. This is 0 plus minus I 2 times. So how will you write the solution? For the first root, alpha is 0, beta is 1, but it is twice. It is twice. So y
E raised
is
to
equal
0.
to, yes, e raised to 0
E raised
x.
to
C1 plus C2x.
Very good. C1 plus C2x. As it is repeating twice, two constants should get
Cos
collected.
x.
Cos beta. Beta is 1. So cos x
1.
1
plus
x.
C3.
C3 plus C4x.
Very
C3
good.
plus C4 x.
Into sin
Sin.
x. Very good.
Plus.
Completed for first root. Now for second root. It is 4 times there. So plus e
Plus
raised to
e raised to
minus,
minus
E raised to
0.5x.
yes, into, it is 4 times there.
C5
This root
plus
is 4
C6x.
times. How many constants will it connect?
4.
4. So C4 is already
C5
used.
plus
C5.
C5
C5 plus
plus
C6x.
C6x
C6x
plus
plus
C7
C7x
7x square.
plus
plus C8
C8x cube.
into cos
Cos 0.86x.
0.86x plus
plus
C8 used.
C9
C9 plus
plus
C10
C10x
x plus
C11x
C11
square
x square plus
C11x
C12
square.
x
C12x
cube
cube
into sine
C12x cube.
Sine
0.86 and beta
0.86x.
x. And now
0.86.
this is the total solution. Easy? Just check the root how many
Okay.
times is repeating. Can I give you one question now? Just this is something different again. You need to think for that. Or similar one I'll give to you. Just solve it and tell me the answer. Okay, solve d square minus 1 square into d square plus t plus 1 y is equal to 0. Take it square. Solve this. Write down the auxiliary equation. D square minus 1 square into D square plus D plus 1 square is equal to 0. Okay, then my question to you is, what is the question? What is the highest power of D? D square minus 1 is 0. This is 2 times, twice. And D square plus D plus 1 is equal to 0. This is again 2 times. Okay, what is the highest power? What is the order? In last example, I forgot to tell you that order was 12. Roots were, how many roots are there total? These are 4 times plus minus, that is 8, and this is 4. 8, 4, 12. And constants are also 12. Now in this highest power of D, I am asking to you, what is the order of D?
8.
Is it 8? Everyone? Here it is D raised to 4, and here it is also highest D raised to 4. So D raised to 4, D is base, and 4 plus 4, that is 8. So highest power here is also 8. So D raised to 8. So there should be 8 constant and 8 roots and 8 constants. So solving the first question, we are getting D square minus 1 is 0. Solve it on calculator. Or simply we can write D square minus 1 is 0, that is D square is 1. Taking square root, we get D is equal to plus minus 1. But this is 2 times. That is what we are getting. D is plus minus 2 times. That is 1, 1 and minus 1, minus 1. Correct? Same root we have to write it again. So plus minus 1, plus minus 1. 1 and minus 1 twice. And D square plus D plus 1. The same we have solved lastly. D square plus D plus 1. So I am copying the question answer. Minus 0.5 plus minus 0.86i. This is 2 times. Right? So this is twice, and these are the roots in total. 1, 2, 3, 4. These are 2, 6. But this is twice. One more time. That is again 2. That is total are 8 roots there. So just tell me how to write the solution. How do we write the solution? 1, 1. This is real as there is no I. Minus 1, again real. No I. As there is no I, these are real. 1, 1. Real and repeated. Minus 1, real and repeated. 2 different cases. 2 different numbers. Real and repeated twice. Real and repeated twice. Imaginary and repeated twice. So for first 1, 1. Just tell me the answer for 1, 1. For this 1, repeating twice. If it is repeating twice, we have to collect 2 constants, C1 plus C2x into e raised to 1x. Right? Plus, for second, minus 1. This is also repeating twice. How to write the solution? C1, C2 used. C3 plus C4 x into e raised to minus 1x. Plus, this is done, write for this. Alpha is e raised to minus 0.5x. Alpha is minus 0.5. E raised to alpha x done. But this is repeating twice, so we have to collect two constants together. C4 up to C4 used. So next is C5 plus C6x into cos beta. Beta is 0.86x plus C7 plus C8x into Sine beta
Sine 0.86
x.
x.
Getting now? This is the solution. So I want you to solve some examples at home. So I'll write here and you just try to solve them. So solve. The first question is solve d raised to 4 minus m raised to 4 y is equal to 0. Second, d square plus 1 cube into d square plus d plus 1 raised to 4 y is equal to 0. And one more, d raised to 4 minus 4d cube plus 8d square minus 8d plus 4y is equal to 0. These are your homework for today. If you have any question, please ask now. Is there anyone newly joined after we cut and come back? Is there anyone joined late whose attendance has not been taken previously?